So today we will be covering simplifying rational expressions. So hopefully we recall that a rational number means a number that can be rewritten as a fraction. So 0.25 is a decimal, but it's also a rational number because we could rewrite it as 1/4. We also have rational expressions. A rational expression is a quotient, which remember is another word for division of polynomials. So remember that a polynomial just means that I'm going to have multiple terms separated by addition and subtraction, one variable, and I can have a multitude of degrees. It could be a squared, it could be a third. That's probably the highest that we'll see in this class, but it could technically be any degree. So when we're wanting to simplify, we've looked at a few problems that were similar to this when we dealt with our exponent rules. So remember that when we're simplifying rational expressions, in this case, we have a monomial or one term over a monomial. Those are both still technically polynomials. They just have one term. And we can still simplify them the same way that we've been simplifying. We're going to look for common factors. So if we look at our numbers first, we want to look at what goes in to both 18 and 60. And hopefully we notice that they are both even, so 2 will go into them. However, we want to choose the biggest number that will go into them. And so hopefully we realize that then it would be 6, because 6 goes into both of those. So if we reduce both of those by 6, 6 goes into 18 3 times, and 60 10 times. Also notice that we also have common factors for our y's. So we have 2y squareds on top, 5y's on bottom. And we can reduce these by thinking about it as subtraction or reducing the number of y's that we have on top into the y's that we have on bottom. So 5 minus 2 gives us 3y's, but they will still be in our denominator. So our answer in this case would be 3 divided by divided by 10, y to the third. And so that would be our final answer. All right, next up, this time we have, it's still a rational expression, but this time we have a trinomial on top and a binomial on bottom. So notice that we have more terms this time. We're still looking for common factors. The only difference is that we're actually going to have to factor these expressions in order to be able to see those common factors. So we've gone over a little bit of factoring, and so hopefully now we can use those factoring skills to help us reduce these expressions. So notice on top we have a trinomial. So I'm going to use the AC method. Remember that you're allowed to use whatever method is helpful to you. So I have a times c, so 1 times -12 gives me -12. So I'm looking for two things that multiply together to give me -12 that add together to give me 4. So we want to go through our factors. 1 and 12, they don't add to 4. 2 and 6. Okay, so if I have 2 and 6, if I add those together, I get 8. But notice that we have a negative 12, so one of those numbers is going to have to be negative. So if I were to subtract 6 and 2, I do get 4. Because the 4 is positive, we do want the 6 to be positive and our 2 to be negative. Now, we could go through these steps of then factoring out that numerator. But remember that as long as my leading coefficient is 1, which in this case it is, these two numbers that we get here will just be my constants for each of my factors. So it's going to factor to x plus 6 times x minus 2. Now notice that as of right now, that's not going to reduce it with anything in our denominator. But recall, we always want to look for a GCF. So for 3x minus 6, we do have a common factor of 3. So we have 3 times, and we would have left over x minus 2. So now notice that our numerator and denominator have a common factor of x minus 2. So we're going to reduce those. So in our numerator, we're left with x plus 6, and our denominator, we're left with 3. So we could either write it as x plus 6 all divided by 3, or we could move that to the front and say 1/3 times x plus 6. Now, it is important to note. So these equal signs mean that the first expression, no matter what I plug in for x, is going to give me the same thing as my last expression if I plugged in that same number into the last expression. And that's going to be true for everything except for 2. Because notice, if I plug in 2 here, I would get 1/3 times 2 plus 6, which would give me 2 plus 6 gives me 8. So I end up with 8/3. However, if I were to plug in 2 into that beginning fraction, we would have 2 squared gives us 4, plus 4 times 2 gives us 8, minus 12 gives us 0. And notice on bottom, if we do 3 times 2, that gives us 6 minus 6, which is also 0. So notice that 8/3 and 0 divided by 0 are not equal. And the reason for that is because we reduced out this factor, but it still causes a restriction. So remember that for our rationals, our denominator is not allowed to equal 0. And because it's not allowed to equal 0 here, it's also not allowed to equal that same thing that would have made it 0 here. So notice that 2 is what's going to make my denominator 0 in this case, which means that x cannot equal 2 for my beginning fraction, which also means that I will have that same restriction that x cannot equal 2. But in this case, we have to add it on because we no longer can see that restriction because we made it go away or we reduced it out. So we have to make sure that we know these things will all equal each other as long as x does not equal 2. All right, so next up, again, we're looking at a rational expression. Again, we have a binomial and a trinomial, so we need to factor it. So notice on top, we have a greatest common factor of 4. So we would factor out our 4 and we get x plus 3. Then in our denominator, we are looking for using our AC method. So a times c gives us a negative 18. So we're looking for two things that multiply together to give us negative 18, that add together to give us a negative 3. Again, going through our factors, hopefully we notice that if we combine 6 and 3, that would give us a combination of 18. However, notice that they're both negative, so one of those will have to be negative. In this case, our 3 is negative, so our 6 is what's going to have to be negative this time, or the bigger number of the two. Again, our leading coefficient is 1, so I can just use those two numbers as my constants. So we're going to go in. Hopefully we notice that we have an x plus 3 as a common factor. So we reduce that common factor out. We're left with a 4 in our numerator and an x minus 6 in our denominator. Now hopefully we haven't forgotten, we still have to write that restriction. So if we weren't able to tell what our restriction was right off of the bat, we can always look at, okay, x plus 3 is what I reduced. What's going to make that 0? So I set it not equal to 0. I would subtract 3 from both sides. So I know that my restriction is that x cannot equal negative 3. Now in that case, if you just could see that it would be negative 3 that would make that expression 0, you can just write it. But if it's something a little bit more complicated and we can't quite tell just by looking at it, this process will always work. And so that would be my final answer. All right, next up we have multiplication. Multiplication is going to be very similar to just our simplify. The only difference now is now that we have two fractions instead of just one. But let's take a little reminder. So if I had something that looked like 2/3 times, let's say 12/4. Obviously, our second one could be reduced automatically. So if we wanted to reduce that, so 4 goes into itself one time, and 4 goes into 12 3 times. But hopefully we also remember, so we can reduce things vertically like we've been doing in our previous examples. However, now that I have a multiplication problem, I can also reduce diagonally. So notice that 3 goes into itself one time and into itself one time, and now we can just multiply straight across. 2 times 1 now just gives me 2. 1 times 1 also gives me 1, so I would have 2 divided by 1, which is just 2. So we could have done it that way. We also could have multiplied just straight across to begin with. So we have 2/3 times 12/4. So multiplying straight across, we get 2 times 12 gives us 24. 3 times 4 gives us 12. 24 divided by 12 gives us 2. So notice that we get the same thing either way. And in this case, it doesn't really matter because 24 divided by 12 is pretty easy to reduce. However, when we're looking at things that look like this, or the problem that we have here, we don't want to multiply that out first. Because if we were to do that, we would end up with a really long, kind of messy problem. And so we do want to go ahead and reduce any like terms or like factors that we have first. But in order to be able to do that, that does mean that we need to factor. So I'm going to go ahead and come over to the side first and factor some of those things. That way I'm not doing it inside of my problem. So notice that our first numerator is 2x squared plus x minus 6. I don't have any common factors, so I am going to have to use the AC method. Notice that 2 times negative 6 gives me negative 12. So I'm looking for two things that multiply together to give me negative 12, that add together to give me a positive 1. Well, I can use 3 and 4, but because my 1 is positive, we need my 4 to be positive and my 3 to be negative. Filling that in. So then I'm going to use those two terms to break apart my middle term. This time my leading coefficient is not 1. So we can't just say x plus 4 times x minus 3, because then I would not get that 2 that we have out to the front. So we do have to break apart our middle term and then factor by grouping. So I factor out a 2x from my first group, and I'm left with x plus 2. I factor out a negative 3 from my second group. I'm also left with x plus 2. Now we have x plus 2 times 2x minus 3. And so we can substitute that in now for our top expression. Hopefully we also notice that our denominator on that first expression can also be factored. So I'm looking for two numbers that multiply together to give me negative 5, that add together to give me a positive 4. So my numbers are going to be 5 and negative 1. All right, then in my next one, I have a cubic in this case, but hopefully we notice that all of those in that numerator have an x in common. So we want to factor that out because it's going to make our lives a little bit easier. So I would be left with x squared minus 3x plus 2. And now we're just going to have to factor that quadratic trinomial, which is going to be a little bit easier. In our bottom, in our denominator of our second fraction, we have a common factor of 2x. And so then I would be left with 2x minus 3. Now I'm going to go ahead and start reducing some of our common factors just so that it's less to write in the next step. So notice again, we can reduce diagonally. So we have 2x minus 3, and we can also reduce vertically. So I can reduce those x's. Now we do need to factor that second numerator as well. So in my first fraction, I'm left with x plus 2 divided by x plus 5 times x minus 1. Now if we factor that second numerator, I'm looking for two numbers that multiply together to give me a positive 2 that add together to give me a negative 3. Those two numbers are going to be a negative 1 and a negative 2 divided by, and notice that we're only left with 2 in our denominator. Now my last step is going to be to reduce any last common factors that we have, which notice is x minus 1. So my last step is going to be just to write what we have left over. So combining that, I have x plus 2 multiplying straight across. So x minus 2. Again, multiplying my x plus 5 straight across. I'm going to go ahead and write that 2 first, just because it looks a little bit nicer. It's not wrong to write it second, but usually we just write our single number out to the front of our parentheses. Now, notice that we did reduce some factors. So we do need to come over And look at what did we reduce? Well, we reduced 2x minus 3, so that cannot equal 0. We reduced an x, so that cannot equal 0. And we reduced an x minus 1, so that cannot equal 0. Solving our first one, I would add 3, divide by 2, so x cannot equal 3/2. Lucky for us, x cannot equal 0 is already simplified, so we know that that will be a restriction, and then x cannot equal 1. So all of those are going to be restrictions, and I need to put them on at the end. And we can just write them as a list. So we're going to put x cannot equal 0, 1, or 3/2. Now, you might say, well, x can't equal -5 either. And that's true. But the reason we want to list out these is because we've reduced those and we can no longer see those in our final answer. We can still see the x plus 5 in our denominator, and so we can still see that that's going to cause a restriction. So if you wrote out the -5 in our restriction list as well, it's not wrong. I wouldn't count it wrong. It's just not necessary because we can still see that restriction in our final answer. Next up, we have division. So division is going to be very similar to our multiplication. So hopefully we recall that we can rewrite division as a multiplication problem. And so that's going to be our first step when looking at a rational division problem. So what we want to do is we're going to keep our first fraction, change our division symbol to multiplication, and flip that second fraction. Or in other words, we're going to multiply by the reciprocal of our second fraction. So that will become x cubed plus 8 divided by x squared plus 2x plus 4. So then we want to start factoring all of those things that are factorable, which in this case is going to be all of them. So hopefully we notice that I have a difference and sum of cubes, and I have a difference of squares. Which, lucky for us, we know both of those formulas. So remember that our a in this case is going to be x for our cubed formula, and our b value is going to be 2. So we have a, b, a squared, a, b, b squared. And then remember that our signs are going to be the same, opposite, always positive. Divided by, notice that I have x squared minus 4, which is going to be a difference of squares. So I have x minus 2 times x plus 2. Then in our second fraction, in our numerator, this time we have a sum of cubes. However, I still have an 8, so my b value is still going to be 2. My a value is still going to be x. The only difference is now when I do the same sign, it's going to be addition. Opposite sign is subtraction, and then always positive. Now, hopefully we notice that x squared plus 2x plus 4 is my second factor that I got up top when I used my cubic formula. And hopefully we recall that I said that that second factor is never going to factor any further. And I say that because if we look in our denominator of our second one, that's also what we have there. So we know that that's not going to be factorable. However, if we didn't know that right off the bat, we can say, okay, A times C gives me 4. What multiplies together to give me 4? That adds together to give me a positive 2. And there's not going to be anything. So that cannot be factored any further. And that's okay, because it's still going to be a common factor for our numerator. So I have an x minus 2 on top and bottom. Then diagonally, I have an x plus 2. And I have an x squared plus 2x plus 4 diagonally as well. So we have a lot of things that have gone away. So if I rewrite this, I have x squared minus 2x plus 4. And on my denominator, I would just have 1, so I don't need to rewrite that. However, we do still have to do one last step. We need to figure out what our restrictions are going to be. So hopefully we can tell kind of off the bat that 2 of our restrictions are going to be fairly easy. I have x minus 2 cannot equal 0, which gives us that x cannot equal 2. And I have x plus 2 cannot equal 0, which is going to give me x cannot equal negative 2. Now, the other problem, or the other restriction that we're going to have, is going to be our x squared plus 2x plus 4. Now, we're going to solve this the same way that we would if we just had an equals 0 there. So it's a quadratic, so we have a couple different options. We can, 1, factor. The problem is we said that x squared plus 2x plus 4 does not factor. So then remember, we have a few more options to solve quadratics. The first is completing the square. Most of the time, most of us don't remember all of those steps. So I'm going to go ahead and not do that one. However, we do have another option, which would be the quadratic formula. So remember, just a side note, that our quadratic formula is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there is the little song, "To Pop Goes the Weasel." If that helps you remember it, then great. If it doesn't and you just want to memorize the formula, that's okay too. All right, so using that formula, I get x equals negative b is going to be a negative 2 plus or minus the square root of b squared gives us 4 minus 4 times a is 1 times c is 4, all divided by 2 times 1 is just 2. So I get plus or minus the square root of 4 minus 16 divided by 2, which gives me negative 2 plus or minus the square root of negative 12 divided by 2. Hopefully at this point we can see that, oh, we have a negative underneath our radical, which if we recall back to Algebra 2, I know it's been a little bit, that if we have a negative underneath a radical, that means that it's going to be an imaginary number. Which for us, we don't have to worry about, because when we're looking at restrictions, we only want to look at our real number restrictions. So we're only going to use that x cannot equal 2 and negative 2. We don't have to worry about the imaginary number because it's not going to be a real number restriction. So the minute that I see this is going to be imaginary, I can go ahead and stop there, say I don't need to worry about that one. And then this would be my final answer. All right, so there we've done simplifying rational expressions, and we've done multiplication and division. In our next lesson, we will go over addition and subtraction.